Hi, let's solve the third question from today's bi-weekly contest, that is maximum number of operations with the same score second. So in this question, so it is an extended version of the first question that we have. So in the first question, we only had one operation, remove the first two elements and delete them. Here, two more operations are added. That is, take the last two elements and delete them, or take the first and last element of nums and delete them, right? So now we have three choices, right? So one operation includes these three choices, and among them I have to choose such that, see, the score is again the same, that is the sum of the deleted elements, and you need to find the maximum number of operations that can be performed such that all the operations have the same score. And doing this, return the maximum number of operations possible that satisfy the condition mentioned above. All right. So now let us go ahead and look at it. So what are we being told? So we are told to perform an operation which has three choices. Either I can take first two elements. Let me change the pen. Either I can take first two elements, or I can take first or last element, or I can take last two elements. So these are the three operations. This is the one operation, right? And there is a choice between these three operations, correct? Then doing this, again, I have this score. Score is the sum of the deleted elements, right? And your task is to find the maximum number of operations that can be performed, right? Such that all operations have the same score. So one thing is clear. First thing is that, let's say I make the choice for the very first operation I'm talking, right? For the very first operation, I make the choice to take first two elements. So in this case, my score would be 5. Let's say I choose, so this is for first two elements. Let's say I take last two elements, right? First operation, again, this is for the first operation I'm talking about. The score will be 7, 3 plus 4. And the third choice for the first operation is I take the first and last element. So score again in this case would be 3 plus 4, which is 7. Now look, the thing is, if I have decided to go with the first operation with score 5, then all the subsequent operations, right? In those operations, again, I can have three choices, but score is going to be fixed. That is 5. So I have to check for 5, right? Let's say I choose this. So my array would be 1, 2, 3, 4. Now here I can take these two elements, right? So their sum is 5. So it is not necessarily I have to take these two. Again, I'll be for the remaining array, I'll be having three choices. So in those three choices, I can choose any of them, and but the score should be 5. Score should be 5. So that is I'm sure. So in the first operation, you have to choose, right? And after choosing, you have to go and check for all the three choices with this score. With this score. So in the first question, you saw that. Let me show you. So in the first question, what it was, the score was fixed 5, correct? And you were only taking two elements, and you were moving forward and only checking this sum, right? This particular sum that you were checking. But in this case, you can have three choices each time, but you have to decide in the first operation what choice you want to go with. Is it with the score 5? Is it with the score 7? Or is it with this score 7? Which is again, so it's the same here, but in other test cases, it might not be the same. So I hope you understand, right? So for the first operation, you have to make a choice to fix this score. After fixing this score, again, you will be having three choices. And now you have a fixed score. You don't have to decide now for the score. And you have to simply check. If I remove these two elements, what will happen? If I remove these two elements, what will happen? If I remove these last two elements, then what will happen? Correct? So that is what you have to keep doing. And you have to return maximum number of operations that you can perform, right? So what here I have to do is I have to return max of, let's say, with score 5, or the operations in which I choose the score 7, or I choose the score 7. So maximum of this I have to basically return. So I hope the first operation is clear to you, right? So then after you choose 5, let's say, then you again have three choices for each and every step with the score 5. So by now it must be clear to you that because you have to check all the possibilities, like, right? So that means you have to choose recursion in this case, right? You have to choose recursion. There is no way that you can consider all these choices. Okay. So now I'm clear. So let's see how we will be doing recursion. So I've already made the recursion tree for you. So as I said, you have to make a choice for the very first operation. So here, as we saw the score with the score 5, we had a choice. With the score 7, we had a choice. With the score 7, again, we had a choice. So we had these three choices, and out of them maximum, we have to simply return. Now, at each and every of these recursive calls, we'll have three choices. What are those choices? To include first two elements, first or last element, or last two elements, correct? So that is what I'm doing here. So how I'll go about this recursion is to make choices for these indexes. I'll simply be doing a recursion which I'll take an I index, which will be the starting index, then jth index, which will be the ending index of that particular array. So this is the section that I'll be considering. Then I'll be passing this sum or score, all right? Then I'll be passing this score, and then with this score, I'll be checking which is the maximum, correct? Value that I'm getting, all right? So that is it. These are the three parameters that are necessary for us to do the recursion. That is I, j, and that sum. So here the sum is 5. I, j we are passing. Nums array obviously we have to pass. Then what we'll do? Make a choice, right? So if we make a choice of having this first two elements, then we will be left with 3, 4, these two elements, right? And we will be at fourth index here because we were already at the second index. Here we'll be at 4 index. So 4 to n minus 1, which is this, right? So from fourth index is this. So this section of the array we are considering, right? So that is it. Now, when do you have to return 1? You have to return 1 when you are able to perform the operation. That means you are choosing, right? Here what you chose the first two elements if their sum is equal to 5. So here you can see it was not, so I returned 0. So let's say the sum here in this case, that is if you include first and last element, it is 5, so I returned 1. So again, when you choose the last two elements, it is 7, correct? So we returned 0. Now let's talk about the base condition for this recursion. So I hope it is clear to you, right? What we have to do, we have to do a recursion. Let us discuss the base condition. The base condition would be when your I is greater than equal to j. This would be a base condition, and your I should always be less than n. If it is greater than or equal to n, then also you have to return 0. Or if your j is, it should be greater than equal to 0. But if let's say it becomes negative, that means you have to halt the recursion. So these are the base condition, right? This is the base condition that you have to check. Then we'll simply check for this, that if the sum is equal to this, by simply having an if condition. Now, how to choose, how to get the maximum out of this? So here we'll be taking a counter, right, which will initially be 0. Then we'll iterate for this recursion, for this recursion, for this recursion, right? So we'll take the CNT and we'll simply calculate here. CNT is equal to maximum of whatever it already has, and after making this recursive call. Similarly, we'll do for this, and in the last we'll be left with the maximum counter, and that will return from the recursion. Okay, so I hope the base condition is clear. You have to return 0 in the base condition, and you have to return counter in the last, right? If you are not in a base condition, right? So initially it will be 0. Why 0? Because we have to check for all these operation, and the minimum that we can get is 0, right? Here we are returning 0, here we are returning 0, right? So initially it will be 0, and we have to calculate what we are getting. Now after this whole recursion, right, you have to return the maximum out of these three recursive calls. After these three recursive calls, so in this call you can see your counter by the end would be having 3. Okay, here in this recursive call you can already see it, the counter will be having 1. Then from this recursive call it will be having 1 again. So you can see that the maximum out of these three is 3, correct? So that is our answer. Now We know we can solve this using recursion, but obviously it would give us TLE. So is there any scope of applying dynamic programming here? So for that, we have to check for overlapping subproblems. Now for this particular case, we are not able to see overlapping subproblems because the test case was very small. But if you'll try to, try to run this for bigger test case, then you will be able to see overlapping subproblems. That means I can apply DP here. So we can simply take this recursion and apply memoization. So we'll have our DP. So now what should be the size of the DP array? First, let us discuss the recursion, okay? So let me go here and show you. Just ignore these DP lines for now. So as I said, inside this recursion function, I have to pass int I, int j, int sum, and this nums, n is the size of the array, and ignore the DP part. So I to j is the section that we are considering, the array after performing the operation, okay? The sum is, as we discussed, we have three choices for the sum. That is, what are those three choices? We have score as 5, 7, 7. So that we have to pass, that is the sum, then the nums array, then the size of the array. Then the base condition, as I said, it's the base condition, you have to return 0. Then you declare the counter variable and you simply check if the sum is equal this, take the counter variable and calculate the max. Okay, so this is supposed to be counter. All right, so you take the counter and here you calculate for counter, and 1 plus if you call recursion after trimming the I plus j part. Okay, so here I plus j basically means taking the first element and the last element. I and I plus 1 means first two elements, and j minus 1 means last two elements, right? So for these three choices, you have to make a recursion, right? But only when the sum is equal to these, right, of the elements that you have chosen, right? If the sum is equal, otherwise obviously you don't have to make the recursive call. Correct. After that, you will be able to calculate your maximum, and here you can simply return your CNT, right? Actually I solved using ans variable, but because I explained the first question using CNT, so that is why I was changing these to CNT. All right, so after that you can return CNT, and that's it. That is the recursion. And now here what you have to do is first calculate S1. So here consider first two elements, what is the score? If you take the last two elements, what's the score? If you take the first and last element, what's the score? And you have to have three recursive calls, right? You have to take the maximum of these three recursive calls, correct? And that is what you have to return. So here this one, and this one, correct? Because score after first operation only you can fix. So we have to do this first operation here only, and then we can simply return 1 plus maximum of out of these three recursion that we are going to get. So I hope you've understood what the recursion is going to look like. Now, as I said, there are overlapping subproblems. You can try out a case in which there are more array elements, and then you'll be able to see. So we can apply dynamic programming. So here the catch is, what should be the size of the DP array? So the size is going to be 2D, all right? And it is going to have I and j as inside of it. Okay, why? Because see, only I and j are changing in this recursion. Sum is going to be constant, nums is going to be constant, n is going to be constant, dpr is going to be constant. So only these two parameters are changing. That means it is 2D DP problem. So inside of 2D DP, declare a 2D array. So here I have declared my 2D array and I have initialized it to -1. After this, I have simply memoized the recursion. So I have said if dp of I is not equal to -1, right, return dp of j. So let's say I have already calculated this dp of j for this particular index that I'm making recursion. If I've already calculated it, simply return it. Why calculate it again, right? Why go and again do recursion? So if you have not, do the recursion and then simply take the answer, the counter here, right, and store it inside of your dp I of j. And this way you'll be able to memorize it, and hence this is a 2D DP problem. So now I hope you've understood it. If we talk about the time complexity and space complexity for this problem, so the space complexity, as you can see, is going to be big of n square, because the size is of the DPR is n into n, and also because of the recursion stack we will be having, so it is also going to be n square. So basically the space complexity is big of n square. Talking about the time complexity, so you can already see that here we are making some recursive calls, right? So at each index we are having at most three recursive calls, and then we have, because we have memoized it, right? So what we have basically done is we have reduced these calls here, right? So the time complexity would become big O of n square only. Why? Because see, we are iterating here once, right? And because we have two parameters that are changing here, so it will be n square. So I hope it is clear to you how you have to solve this question, why we are applying recursion, how we have applied recursion, and how we have memoized it. So that is all about this particular problem.